Okay, good morning. So today we want to start, and so we did some recap from Math 3C, but that is the new lesson, okay? And that is an extremely important lesson. Might be, I would say, the most important topic in this chapter. Okay, so the chain rule, if I see what we have done so far in the recap we had in Math 3C, we learned about the derivative of these functions. These blue ones that you see here are special cases of this one, which I think is worth to remember, especially for the exam. So this is for different functions, but we have three generic rules here, which applies to whatever function you have. So the sum rule, the difference rule, and the number c multiplied by f rule. So today we want to add one rule to these generic rules, okay? So we will not add something to this table yet, but we will add probably the most important generic rule under the title of the chain rule. You will learn probably, you will see that in the future you will also appreciate why the name is called the chain rule. It reminds you of some kind of loops of chains that coming one after the other. But to motivate you, let me start with a simple example. And by the way, this is the miracle that we have this rule. It seems that God is on our side, yes. Otherwise, the notion of derivative was useless, mainly. So I want to motivate you. For example, if I give you this function, e to the, let me write y equals to e to the power of x. If I ask you what the derivative of this is, it's in the table. If I ask you what the derivative of e to power x to the power of 2 is, it's not in the table, okay? Because this is x to the power of 2. But still, the question is the same. What is the derivative of this function? So this is the topic of the chain rule. If the chain rule was not the rule that we can apply, then we don't know what to do. We have to solve each problem case by case. Okay, so that is why probably even the tables are not useful. Because the table is useful when you have the formula and you can apply it in different circumstances. If you cannot apply it for this one, and then of course you have to have another formula in your table for this, and then I change it to 3, and then you have another formula for 3, so it doesn't work. Okay, so that's why I'm saying it's a miracle that we have this rule. Okay. Or if I want to make it a little bit simpler, so let me start with this. Y equals to x to the power of 2 plus 1 to the power of 2. If I ask you differentiate this, you can immediately do that using Math 3C, even Math 3C knowledge, yes? But you said yourself that, okay, this is not exactly in my table, but it is not a big problem because I can expand that. First one squared, 2 times the first one times the second one squared. Then I know what to do with this, with that, and I have the sum rule and rule number 3. Together, the derivative becomes 4 cubed plus 4x, and that's it. But of course, the problem is that if I increase the power to 20, of course, in principle, it works. But I have to multiply this by itself 20 times or use Newton's binomial theorem, whatever you want to do. Then you expand it, it becomes a long expression, but in principle it's doable. Okay, but then, because I don't care about you, I can increase the power. Yes, but in principle, you can do the same thing, multiply this by itself 2,000 times or use the theorem. So this is not a problem which is in principle hard, but it is calculationally demanding, okay? But it is possible. But in the previous case, as I told you, I don't know even what happens if I increase this power 1 unit. Okay, so if I write e to the power x squared, here, if I'm crazy enough, I can sit down and expand. Yes, but here there is no expansion involved. Okay, so how can probably the most relevant function in my table is that one? How can I make sure? So you might say that, okay, this is also the same thing. Who cares? Yes. You might say that, okay, e to the box, if you interpret it in that way, you say that this is e to power the box. Now box is x squared, so I will do the same thing. Now it turns out that this is not the correct way to do this. Okay, so I just want you to know, even for a simple change as putting a power 2 here, you don't know what to do. Okay, so we need some kind of rule that we can use, and that is the topic of today's lesson, the chain. But instead of, in order to write the chain rule, so here I want you to understand two things. Okay, so let me clean these, and then, and if you don't mind, let me call this function h of x, and another function h of x is e to power x squared. Okay. So we want to see the same these two problems from another perspective. My question is that, can I compose? I will explain what do I mean. Can I compose two functions whose derivatives I know, and it gives me h of x? Okay, so let us talk about what is the meaning of function composition. Okay, so I want to talk, this is something that you already know, but probably you don't know the name. So for example, if I give you a function f of x equals to, let me make it very simple, 3x plus 5, and I give you another function g of x, so let us say that it is 5x plus 2, okay? And if do you remember when we were dealing in Math 1C, we learned about how to calculate this expression, f of g of x, okay? F of g of x, we didn't give it a formal name, but that is the composition of function f and g. And the best way to read it is to read it f after g. So, because you are not confused. Some people think that f applies first. This is possible, but don't think in that way. So mathematicians use this symbol to say f applies after g. Okay, so let us see what happens here. F applies after g, it means that f has to wait, so g does the job and gives an output. Then f will take that output as its own input and do something on it according to its rule. Okay, so let us, if I ask you what this is, I told you that f after g means f has to wait so that g is done. But when g is done, what is the role of g? G takes an input from you, whatever it is, let us call it x. It multiplies the input by 5, adds 2 units to it, and gives it back to me. Now g is actually applying on x. So what is the output coming out? Is 5x plus 2. Yes? But now, after g is done, f after g, f is supposed to apply now. But you need to understand what f does. What f does? It takes your input, whatever it is, you call it x, multiplies that input by 3, adds 5 to it, and gives it back to you. Now, f is receiving this input, so it will do the same thing. It will take the input, multiplies that input by 3, and adds 5 to it. Yes? And of course, if you want, you can simplify this. 3 times 5 is 15x, 3, 6, and 11. That's the output. Okay? So, but you see that this itself is a new function. So if I want to draw a diagram for you, I send x to g. So let us denote g by a black box. The output of g is what? Is 5x plus 2. Then I send this to another machine. So because it's another machine, so let me draw it with a circle, f. And it gives me, after that calculation, 15x plus 11. Okay? Now, if I put these two machines in a box, yes, these dotted machine or blue machine, what does the blue machine doing for me? It receives x from me. What does it do? It multiplies it by 15 and adds 5 to it. Okay? So this blue machine is also another machine itself. Yes? I am sending x in. What do I get out? 15x plus 11. This is called the composition of G and F, but F after G. Okay? F is coming after G. So this is called F after G. In your book, they haven't used the notation. I don't know why, but the notation mathematicians use for F after G is F, a little bit circle like this, and then G. They read it F after G or F-O-G, but that's not an O. Okay? So, and then you can call this whatever you want to. For example, I can call it H. So H is the composition of these two functions, f and g. Is that clear? So if you don't mind, let us do some practice. Let us calculate, let us identify or specify what is g after f. Okay? So what is g after f? G after f means this time I send x to which machine first? G after f. So f has to apply first. What is the output coming from f? F multiplies the input by 3, adds 5 to it. So it will do the same thing here. So 3x plus 5. Now I take this output from my first machine and send it to the G machine, yes? But what this will do for me, G always multiplies by 5 and adds 2 for whatever input I put. Now this is the input I am sending to this machine, so the function will do the same thing. Will take my input, which is 3x plus 5 now, multiplies my input by a factor of 5, and adds 2 to it. Is that understandable? Yes or no? So what the answer is? 15x plus 17. So 15x plus 17 comes out.
27.
What?
27. It's 5 times 5.
Ah, that is 5, so yeah. I cannot read my own handwriting. So 15x plus 27. And of course, at least you can see the outputs are different, so it matters in which way you compose the functions, f after g or g after f. There is no guarantee that the final results are the same. But again, you can consider this a new machine, so let me draw it with the dotted oval. Okay, so what this machine is doing, this machine is receiving an input, call it x, and gives me this back. Yes? Here, this is G after F. G after F in mathematics. This is not used in your book, but I just want you to know that. It is G O F. But I am not allowed to call it the same H because that's not the same H. This machine multiplies by 15, adds 11. This machine multiplies by 15 but adds 27. So if I call the previous one H, I am not allowed to call this H again because it is doing something else. So if you don't mind, let me call it capital H, for example. Okay? But that I don't want to go deeper into it, but that is the idea of function composition. Okay? Now, in your book, this is not written in that way. They write it always in this way. So f after g is this, which in my notation, I call it h of x, is f after g. And g after f is denoted by g of f of x. And in my notation, I called it capital H. But this FOG or GOF is not the symbol that you will find in your book. This is the symbol, the way that you use it. Okay? Okay. And by the way, there is also a name in your book. The function that you see that appears inside, it is called the inner function. Yes? And the function f that appears outside is called the outer function. Okay? Here, the outer function is g, the inner function is f. So these are the names the book has used. But now, how is it relevant to the notion of derivative? This you need to understand it good. The point is that you need to ask yourself, is it possible for me to find two functions, for the time being only two functions, for which the composition of those two functions gives me this function? On the other hand, I know the derivatives of those two functions. If the answer is yes, the chain rule tells you how to differentiate this new function. So the chain rule is a rule that tells you if a function is composition of two functions, how the derivative of this is related to the derivative of f and g. Okay, so that is the chain rule. I haven't mentioned the chain rule yet. I will tell you how it looks like, and I will add it as the fourth generic formula here. But I want you to understand the essence. The essence is this. If someone tells you what is the benefit of the chain rule, you will tell that the chain rule is the rule that enables us to determine the derivative of a function, okay, in terms of the derivative of the outer function and the inner function. Yes? Is that clear? Okay. But the first practice is to be quick at it. Can you give me two functions? This is important. Now let me keep it and go down. So for the case hx squared plus 1 squared, can you imagine two simpler functions so that when I compose them in any order that you prefer, it gives me the function h of x. So let me again ask the question. So the function that I am interested here is x squared plus 1 to the power of 2. Now I'm asking you the question, give me two functions, let us say f, let us follow the book, f the outer function, and g the inner function, so that f after g becomes h. This is one constraint. The more important constraint is that you should be able to differentiate f and g, because sometimes it is not unique. You can find different answers, okay? But you need to choose the one that you know how to differentiate both using that tip. Yes, Afsh?
F of x can be x squared, and g of x can be x squared plus 1.
So, this I want you to be quick. Okay, so let us try. If you have a little bit of doubt yet, this is completely correct. So let us, if you don't believe, you have to calculate f of g of x to see if it works. Okay? So Hafsha was good in detecting these functions, and this is possible. This is not very hard thing to do. Okay, but I will double check why what she said is working. In order to double check, I have to calculate this and confirm that it becomes this function. Okay, this is f after g. So f has to wait because f is supposed to come after g. G applies first. According what she said, g applies on x gives you what back? This back. Okay? And now what you are supposed to do, f is supposed to apply here. What is this machine? This machine is the squaring machine. Whatever you send in, f squares it and gives it back to you. Now what you are sending in is x squared plus 1. So f will square it and gives it back to you. Okay? But is this function the function that I want? Yes. So that is h of x. So yes, this process, you have to be skillful at it. Okay? It's not hard, by the way. By the way, one way to imagine this, if you want to calculate this using your calculator, if I give you x to be 5, what do? You first put 5 here and calculate this, okay? And then you square it. You see, this is, yeah, so it means that the first thing that you calculate is the inner function, and after that, you square what you got, which is a squaring function. That's also one way of understanding this, but you don't need to worry about it. I'm sure that you can do it very quickly. Okay, so let us test your understanding for the next function. Okay, by the way, Is it a good decomposition? Yes, because if I ask you, do you know the derivative of this? The answer is yes. Do you know the derivative of this? The answer is yes. Well, that's good. Okay. So what about the other one? Anyone else? H of x is e to the power of x squared. Can you see the other function? Can you see the inner function? What is the inner function? You imagine in this way. Let us assume that I give you x and you are supposed to calculate. What do you do first? Yes?
X squared.
X squared. You do x squared first and you get something. Let us say 10. And then what do? E to power 10. So what would be the outer function?
E to x.
E to power x. Is that understandable? Yes? I don't think we need to check it every time. So do you agree? So g apply f after g means g applies first. It gives you x squared. And then f is exponentiating machine. It takes the input from you, exponentiate it with e, and gives it back to you. So when you send x squared in this machine, it will give you e to the power x squared. Okay, is it a good decomposition? Yes, because do you know the derivative? Yes, do you know the derivative? Yes, that's a good code. Okay? Okay, but let me go to another example. What do you think about this? I don't know, let me give you another one. So h of x is equal to square root of x squared plus 5. So, do you see that this is also a composition of two functions? So what is the inner function in this case? So, sorry, what is the other function and what is the inner function? Inner function is probably easier to visualize. What's the inner function?
X squared plus 5.
X squared plus 5. What is the other function?
Square root of x.
Square root of x. So tell me, everyone happy with this? Understandable? Okay. But sometimes, of course, my function is a little bit more complicated. I have the composition of more than two functions. So I have f of g of L of x. Something like that. I can have the composition of more functions, yes? I don't know, let me write f1 of f2 of f3 of f4, okay, 2, 3, 4. Okay, so there is no inner and outer. There is an innermost function, f4, there is an outermost function, f1, but the other ones are intermediate ones, yes? This can happen. Let me ask you one question of this type. So, for example, not a very hard one, by the way, I saw it in your book. So, can you see this is not exactly the code? Of course, you can write it. By the way, let me ask you one question. Can you write this as a composition of two functions? Exactly as before. No, you can. You can, but there is a flaw in it, which we don't want to do. Let us insist to write this as composition of two functions. How do you do that? So what is the inner function?
Square root of x squared plus 1.
X, square root of x squared plus 1. And what is the other function?
E to x.
E to the power of x. First of all, tell me, do you see that f after g becomes this? But this is not good. Why? Because I know the derivative of e to power x. It is in my table. But the problem is that I don't know the derivative of g of x. It is not directly in my table. Yes? So even though this is not wrong, but for the purpose that we want to understand this lesson is not good. Okay? So I have to decompose it more. So I decompose it to more functions. Okay? So let us use indices instead of names. So what is the inner, so I don't know how many functions you can imagine that I compose them and it gives me h of x on the one hand. On the other hand, I know the derivative of each one of them. 3. Okay, so if you say 3, the innermost function, if you don't mind, let me call it f3 of x. And then the intermediate one. And then finally the outer function. The outermost function, okay? The most outer function. So tell me, what is f3? It is very easy. Which part you do first? X squared plus 1. Yes? So x squared plus 1. After f3 is done, which part you do second? you take a square root. Yes? So this is a squaring function. And after all these two are done, what do? You exponentiate. So it becomes e to power x. So these three functions, if composed in the right order, f1 after f2 after f3, it gives me that function. But this is good. Why? If I ask you, do you know the derivative? Yes. Do you know the derivative? Yes. Do you know the derivative? Yes. So this is why the previous one, even though it was correct, it was not useful for our purpose because there was one function involved there that I don't know the derivative to it directly. So is that clear? Yes or no?
Yes.
Okay. Let me give you one more example and then we go, okay? So, h of x, so let me write it in black, h of x the fifth root, the fifth root, let us make it complicated, e to the power of sine to the power of 3 square root of x squared plus 1. Okay? So you see, this is why I'm saying God is our own side, because we can differentiate this. Yes? Because it's a composition of course, you don't know the derivative of sine yet. We will add this later. But in principle, you should be able to tell me how many functions are involved, how many functions I have to compose to get this one in the right order. So, can you tell me what is the innermost? I don't know even how to number them, because how many functions are involved?
4, 5.
So how many functions are involved? So let us name them later. Okay, what is the first function you apply?
X squared plus 1.
Think in this way. If I give you x, what do you do? So it becomes x squared plus 1 first. Yes? When I got the result, what do I do next? I take the square root. So it becomes a square x function. After that is done, what do I do? No, you just jump 2 steps. Yes? I take sine. Yes? I take sine, and after that to the third power. So the next function is sine x. And then after this is finished, I raise it to power 3. So what is the next function? No. x3. And then after that, e to the power of x. And after that, the fifth root. Okay, so 1, 2, 3, 4, 5, 6. So f6, f5, f what? f4, f3, f2, and f1. Yes? So, and that's a good thing, because I can differentiate all of them. You haven't studied only one of them, and that is this one. And you will study. So in principle, because you know how to differentiate all these simpler functions, you can differentiate these so complicated functions. Okay? Is that clear? So that is the whole point. So this is not hard, you see, if you practice. Any questions here? Are you confused or not? Yes? No? Okay. Now, what the chain rule is. I want to write the chain rule without any proofs. You have to trust me on that. We can talk a little bit about the proof if I have time. Otherwise, I will refer to one of the videos if you want to see. Of course, we cannot prove it 100% rigorously, but what is written in the book is good enough, fair enough. Okay, so what this rule is. So what this rule is. This rule is this. If a function h of x, you are able to write it as f after g. If you have this, then the derivative of h is simply the derivative of f multiplied by the derivative of g. Yes, this is a little bit sloppy language, but it is easy to remember. It is f prime multiplied by g prime. Yes, it is a little bit strange. Yes, the derivative of f after g is the derivative of f multiplied by the derivative of g, but there is something very important that you have to pay attention to. Okay, so here you don't need to pay attention, that is the derivative of x, but f prime is not f prime of x, it is f prime of g of x. Okay, it is not f prime of x. Okay, so let me write it in a little bit. So this is f prime of g of x multiplied by g prime of x. And that is h prime of x. Before I use it, you need to understand these two factors. Understanding this factor is simple enough. You have a function, that is its derivative. But understanding this is important. Okay? So here, this, if I want to give it a name, I would say this is the derivative of f at g of x. If I want to give it a name. Yes? But how should I calculate? Let me give you immediately an example so that you can understand. So example, if I give you this function, f of x, matrice problem, very simple one. F of x is 3x to the power of 2 plus 5x minus 1. Okay, I ask you three questions. Number one, what is f prime of 0? Number two, what is f prime? I don't know. F prime of simple things, 1. And finally, I ask you, what is, for example, f prime of x to the power of 2 plus 1. Okay? This, if I want to read it in English, this is the derivative of f at 0. This is the derivative of f at 1. This is the derivative of f at x squared plus 1. Okay? But of course, I hope that you understand the way that I used to solve this part should be the same, identical to the way that I used to solve this part, and identical to the way that I solve this part. They are the same. Only difference is that I have different numbers. For all of them, what is the recipe? If you want to, this is a simple matrice problem. F of x is given, you are supposed to have f prime of 0. It has two steps. Step number 1, differentiate. Step number 2, replace x in the derivative with 0. Okay, so the first thing that I do, so let me write it because it is common to all of these parts. I do it once for all. So f prime of x is 6x plus 5. Yes? Okay, number 1. What is f prime of 0? What do? After differentiation, I replace the x with 0. What the answer is? 5. If I ask you what f prime of 1 is, what happens? I replace x with 1, it becomes 11. Okay? I want you to understand, when you see f prime at something, it means this. Okay, now how can I calculate this? F prime of x squared plus 1 is equal to. I have to replace x. Here I replace x with 0. Here I replace x with 1. For this one, I have to replace x with x squared plus 1. So this becomes 6x squared plus 1 plus 5. If you want to, you can write 6x squared plus 11. Okay? Is that clear? And I want you to understand immediately this symbol and this symbol are very similar, but there is a very big difference between them. So it matters if you put prime here or if you put prime there. I will talk a little bit about that. But what I want to concentrate, you don't have this symbol here. So I will talk about that. It's extremely important to understand. But this one, you have it here, so now you know what to do. Okay? So let me write this down for you, so that as a remark, you can refer to it later. So if someone asks you, what is the meaning of this symbol used? So I would write a remark. F prime of g of x means differentiate f first, yes, and then replace all x's in f prime of x with g of x. Okay? This is the meaning of this symbol, and that's not a hard concept, so you have to remember it exactly as I did here. Okay? But now that I have told you, let me talk about this symbol as well. But so what do you think will be this one? I think you should have a feeling for it yourself. But what does this mean, do you think? Yes?
It's the same as like each prime of x. So
No, what is, forget about the chain rule. What is the meaning of this symbol, yes?
Wouldn't that be just differentiate the constant value?
No?
That was this way.
No, what is the meaning of this?
well, you're
Yes, Sergey?
First you replace in the original function.
And then you differentiate.
yeah.
Yes. So here, this means, but means replace every x in f of x with g of x and differentiate the new function. Yeah, please be quiet. The new function that emerges this way. Okay? And the chain rule tells you that they are not equal. Okay? We can test this idea, by the way. Okay, let me talk a little bit about this. This is extremely important. And the chain rule is the rule tells you how these two are connected. Okay? They are not the same. Let me give an example here. Okay, so let me give you a very simple example without the chain rule. Okay? So I give you a function f of x equals to, say, 2x squared plus 5x. And let me write g of x to be, I don't want to make it complicated, so let me write 3x 2. That's enough. Okay. F and g. Okay, without the chain rule. Momentarily forget about the chain rule. I want you to understand the difference between the notations. Okay, we want to calculate f prime of g of x. We want to calculate f of g of x totally prime. Okay, so let us do this. This one, it is written, means differentiate f first. So in order to answer the question number 1, I have to differentiate f first. As usual, so it is 4x plus 5. And then replace all x's in f prime of x with g of x. So this means that the question mark in this case, which is f prime of g of x, is equal to, I differentiated f first, and to answer this, after that I go and replace x with g of x. Yes? But what is g of x? Is that guy. And the answer is 12x squared plus 5. So you see, you don't need even you don't need to know the lesson, but this is doable. In principle, it is doable in Math 3C as well. Okay, but number two, what does it mean? But this means replace every x in f of x with g of x. So let me write first. And differentiate, and then differentiate the new function that emerges this way. So what should I do first? I need to go to my function. Okay, so I have to calculate f of g of x first. It means I have to replace every x with g of x. Okay, but no one writes g of x because g of x is simple. So I put this here. So it becomes 3x squared to the power of 2 plus 5 times 3x. And then what happens? It becomes 18x to the fourth, and then plus 15x. This is what I get if I replace every x with g of x first and then differentiate. So the question mark here, the second question mark, which is f of g of x, is differentiating this function, which is 72 x to the third and then plus 15. Let me see if I have done something wrong. Because 6x, yeah, I have to have done something wrong. Where is that? Yes, my bad. This gx is not 3x, it's 3x squared. Sorry. So what happens? It becomes 15x squared. And then it becomes 30x. Okay? So you see there's a very big difference. For example, this function is a second degree polynomial, but this function is a third degree polynomial. Okay? So as first of all, you see that they are really different. Okay? But the good news is that chain rule finds a connection between these two. The connection between these two is the derivative of g of x, the inner function. What is the derivative of g of x? 6x. Take that and multiply it here. What happens? 72x cubed, 30x. Okay, so the chain rule is actually the connection between these two. The chain rule tells you, first of all, I want you to understand that these two are different. The second thing is that if you want to tell me what the chain rule is, the chain rule is the rule that tells you how this is connected to that. This is a very important way of understanding the chain rule. Okay? And this tells you what to do. If this h prime of x means what, by the way? It means that you want to take the derivative of h. H is this, and you want to differentiate it. So h prime of x means total derivative is equal to this multiplied by g prime of x. So if you want to, I can write this formula in a slightly different way for you. I can say that f of g of x totally prime is, you can just slip this prime sign here, but that this is not finished. You have to multiply by g prime. I think this is a more powerful way of writing the chain rule. But of course, you see this in your book, which is always, I even haven't seen one single math book written the formula of the chain rule in that way. I don't know why, because that's for me, it's the most natural way to understand this. Okay? Now you understand what is the differences. Okay. Is that clear? Okay, now I want to teach you how to differentiate. Because now we learned what the chain rule is telling to you. We also learned what are the differences between different symbols and things like that. But the main problem is still there. I want to differentiate this function. How can I do that? Okay? So let us try to do this. It is on the board and it is ready-made for us. Yes? So let me clean this here. And let us try to solve this problem together now. I can start from scratch. This function is given. This is what you need to learn. If you're not that type of students who want to learn all these details, but this is the minimum. So this function is given. It's an E-level question. And then the question is that what is h prime of x? This is what I expect you to be able to solve. The first thing, let me start from scratch myself. The first thing that I want to do, I will write this as the composition of some simple functions that I know how to differentiate. So we did this before. The inner function I realize is what? X squared plus 5. The outer function is what? F of x is equal to square root of x. Okay? And I want to know the derivative. The formula in this form is in the formula sheet. Okay? And now you need to calculate g prime and f prime g of x, and f prime of g of x, meaning is clear here for you. So what you do, you need this as one ingredient. It's very simple. What do? You differentiate it. That is the end of the story of g. Yes? We put it in that box. Now we need another thing. We need f prime of g of x. But we know what to do. We differentiate f first. So let us do. Do you know how to differentiate? Yes. It is in the table. But it is not the end of the story of f. Okay? The end of the story of f is that after you differentiate, you replace x with g of x. So the end of the story of f happens a little bit later. Yes? So what happens? F prime of g of x is what? Yes?
The derivative.
Okay, sorry, I skipped that. Sorry. 1 over 2 of square root of x. Sorry. So f prime of g of x is what? I differentiate first and then replace x with g of x. So I have to replace x with g of x. But g of x is in front of me. So I replace x with which expression? X squared plus 5. And now, because everyone is mortal, this is the end of the story of f prime. And chain rule tells you just multiply these boxes. And that's your answer. So the question mark is the product of the boxes. Okay, so it becomes 1 over 2 square root of x squared plus 5 multiplied by 2x. This is finished. But if you're caring about beauty, you care about simplicity. Yeah? So 2 and 2 are gone, so I write it in more compact way. So that is the answer that I expect you to write. And by the way, this is E-level question. I'm teaching you in this way because this is the way that book teaches, and that's correct. I want to have a good understanding, but you know that I'm not that patient to do things, simple things over and over again. Then I will tell you how to do it faster. And that is enough, because that is really important. Okay, because otherwise you have to kill yourself, let alone, so what happens, by the way, if I have a composition of more than 2 functions? Yes, so and if I have a composition of how many functions we had there? I don't know, 5 or 6 functions there, 7 functions. Okay. First of all, do you understand the essence of the chain rule? So if I give you a function, it is not in your table. One of the rules that might help you is the chain rule. That let me add it here, by the way. This is the generic rule that I add here now. So let me write it in my own way. So f of g of x totally prime is f prime of g of x times g prime of x. Okay? So what you do when a function is given and you determine to do it, you realize it is possible to do it using the chain rule, it means that you need to think about two functions, inner function, outer function. The inner function is easy, just differentiate. The outer function, you not only differentiate, but you also replace x with g of x. And then you have two boxes, you multiply them, that will be the answer to your question. Is that clear? I haven't talked about why this is working, but let us learn how to use it for the time being. Okay, so let me give you an example and wait for you to do it, okay? Okay, let me give you the simple example that we start with, yeah? Two of them. So, I told you that one of them was, let me write h of x, and I want to wait for you. If I remember correctly, it was x plus 1, and then I raised 20,000. Okay? And then the next one I told you, or might be the previous one, was e to the power of x squared. Okay, I want to wait for you. Just do that. Okay, so let me explain again if you haven't understood it. Okay, so I can change the battery. You can think a little bit more. Okay, so let us do this again. If you haven't learned, you can listen again. So the first thing comes to your mind. You need to, okay, you want to differentiate this. This is not something that you have directly in your table. One of the rules that might come to your mind is this chain rule. So if you made your mind to use the chain rule, then it means that you need to write an outer function and you need to write an inner function so that when you combine f after g, it becomes this function. Okay, but we did this before. So what's the inner function? X squared plus 1. What is the outer function? What? X to the power of 20,000. Okay? And then you differentiate this g, the inner function, you differentiate 2x, end of the story. But for f, you differentiate, it's not the end of the story. It becomes 20,000 x to the power of, I don't know, something like that. Or one more, yes? Okay? It is not the end of the story. The end of the story is that when you do the replacement of x with inner function. Is 20,000. Instead of x, I put x squared plus 1. And then, of course, you see this power on top, 19,999. And now, this is the end of the story. But the answer to the question mark is the product of these boxes. Just do it in your head. 2x times that is 40,000x. And then this. And that's my question. Yes, understandable. So it is not hard. For the next one, what I'm supposed to do, again, if you decided that this is going to be solved using the chain rule, then you need to find the outer function, the inner function. So do you remember what is the inner function here? X squared, outer function, e to power x. Yes? This one, just differentiate it, end of the story. This one, you differentiate, which of course this is one of the exceptional functions. The derivative is equal to itself. But this is not the end of the story. You have to replace x with gx. So it is e to the power of x squared, and now end of the story. And the question mark is multiplication of the boxes. I prefer to write 2x on the left, but that's not a big problem, okay? That's the answer. That's the derivative. Okay, so that's a simple thing to do. But what happens, we need a chain rule with more functions involved. Yes, because if you remember, I gave you a complicated function. It was a composition of 7 or 6 functions, I don't remember. So we need to know how the chain rule looks like if I have more than two functions. Okay, but I want to rely on your intuition, of course. We can go together. So, for two functions, if I want to differentiate, I differentiate the other function and calculate it at the inner function, and then multiply by the derivative of the inner function. So let me write three functions here. So for example, let me write f1 after f2 after f3. Yes? And I want to take the derivative of the whole combination. So what do you think I will do? In order to, because the formula that I have works for two functions, but I have three functions. But composition of three functions can be viewed as composition of two functions by giving this part a name. If I call this g of x, then I have two functions involved and I want to differentiate. Yes? So according to this rule, it becomes f1 prime of g of x multiplied by g prime of x. Okay? But g itself is the composition of two functions. So I continue one more step. Instead of g of x, I write what it is. Multiplied by g prime of x. But forget everything. This is your g of x. It's a composition of two functions. You want to differentiate it. You have the rule for two functions. So it becomes the outer function derivative calculated at the inner function and then multiplied by the derivative of the inner function. That is your formula. So again, if you have composition of three functions, the derivative is the derivative of each one of them multiplied together. The only thing that you have to remember, the innermost function has its derivative, but the second one is not calculated at x. It is calculated at the innermost function, f3. And the first one is not calculated in f3 or f2, it is calculated at f2 after f3. Okay, so that is something that you need to know. For 4 functions, for 5 functions, we have the same thing. If I want to prove it rigorously, what is the method that I can use? For 4 functions, for 5 functions, for n functions, yes? Yes?
It's like
Yes, we had it in Math 5, mathematical induction, yes? Yes. Because if you want to prove it rigorously for n functions, you can use it for using mathematical induction. First prove it for 2, and then assume that this works for k, prove that it works for k plus 1 as well. Yes? So that's it. But don't worry about this. So I just want to tell you that if you want to see, you can continue this. This formula is not in the book, but it is good to see it once. One more thing that is extremely important. I want you to understand this one as well. And that is this. What is the difference? Is there any difference between... So I told you there is a difference between this one and this one. We learned the difference is, what the difference is, yes? We know that they are not the same in general. But what do you think about this? Do you think it matters, if I have f of x, do you think it matters if I put prime up there or I put prime here? Here it matters. If you put prime here or if you put prime here, they are not in general equal. But what do you think about f of x? Do you think there is a difference between this and that? If there is a difference, we have to respect. If there is no difference, which one is simpler? The second one. So we write the second. Now tell me, is there any difference in this case?
No.
Yes?
No, there's no difference.
Why?
Because when you
differentiate f of x is the same as f prime of x.
Okay, but you just you just repeated why. Why they are the same.
Because
So I just want to understand why this question makes sense even. So the difference between them is just a matter of where you put the prime.
Yep.
If you put the prime there or if you put prime there, I hope that I could convince you that they are not the same.
Yep.
But now I am asking the same question. I put the prime here and I put the prime there, and you are claiming that this time there is no difference, and I want you to defend yourself.
and there's no difference because there's only one function.
Okay, if I insist to push you harder, why? There is no difference here.
The reason there was when there were two functions, they didn't have the same answer, was because
We have two functions.
yeah.
Yes. Okay, let us wait for you. Anyone else? Yes.
I just thought it, but after reading the remark you wrote
Yeah.
there, my educated guess is that there's no difference since x gets replaced by the same number, and since we don't replace x with a function, and thus it doesn't really
Matter.
Yeah.
Okay. What about Hafsha? Do you want to say something?
Because you're replacing x with x, so it would not matter.
Okay, so you are telling the truth, but I want a better truth. Yes.
And it's the order which you do it. So in the second case,
Yeah.
you differentiate f first and then replace by x.
Okay,
in the second.
all of what you're saying is correct, but the way that I want to say it is a little bit different. Yes?
The derivative only changes the order in which you replace things, and we're only replacing one thing, so it doesn't matter.
Okay, that's more or less the same thing as others. Do you have something better to say? Not better, I don't know. From my perspective, of course, it's better. But better is sometimes subjective. Yes, Rasmus, do you want to say something?
I just say because the derivative of x is either way x, so
No, the derivative of x is either way.
just equal to x. Or
No.
it's not.
No, the derivative of x is
Yeah, it's
1. And that is why there is no difference. Yes, because now, what is playing the role of g of x here? That is important to understand. X is playing the role of g of x. Okay? So that is what I'm saying. The chain rule might be we learned it later, but that is more fundamental. So if x is g of x, so what happens? F of x prime means what? Means this is the inner function. The inner function is g of x equals to x. So this becomes I slip the derivative here, but I have to multiply by derivative of g, which is this one. But the derivative of x is 1. Okay. So they are the same. To test your understanding, what do you think about this scenario? Do you think that it matters where I put prime in this scenario? Again, no. Why? Because f of x plus 5 totally prime is f prime of x plus 5 but multiplied by x plus 5 prime. But x plus 5 prime is 1. So this means that there is no difference. So as far as what you have inside has derivative equal to 1, it doesn't matter. Okay? Not only, this is a very a special case that it seems ridiculous to even ask. Okay? But this is not ridiculous to ask about this one, which in this case is true. So as far as you see, this is clear. If g prime is 1, of course this is, if g prime is 1, this becomes equal to that. Okay? So whenever g prime is 1, these two doesn't have any, they don't differ at all. But if it is not the case that the derivative of g is 1, they are different. And how they differ? By multiplication by g prime. Okay? And let me also write some English words for you. This is something, I mean, you can also translate it in Swedish, it doesn't matter. But what I mean, So let me write something here. F of g of x. The derivative of is, so choose one of them. Okay, let me write this. Is number one, f prime of g of x. Number two, f of g of x prime. Which option I should choose? If you see it in English, not mathematical symbols, they say the derivative of f of g of x. Which one they mean? Your intuition, your English, whatever. Yes?
The second one.
The second. Exactly. Okay, so the derivative of this, whatever this is, I want to find its derivative. So it means that you have to construct f of g of x first and then differentiate. Yes? So let me ask you this question. Again, the derivative of f of x at g of x is number one, f prime of g of x. Number two, f of g of x prime. Which one? The first. Okay? So I don't know. I hope that you understand the differences. So this is important to understand. Okay? Why this is important to understand? Let us enjoy life. Yes? So let me ask you some questions. I will go back to solving harder problems, but let us work a little bit conceptually here. So let me try to give you some flavor, okay? So example, yeah, please do not whisper. Thank you. So example, so let me write it in this way. What is the derivative of, let me say, f of square root of x? What is the derivative of f of the square root of x at x equals to 16? So let me write x equals to 4 if if f prime of 2 is minus 7. So let me see if I did it right. Yes. Okay, so these kind of questions, if they want to force you to use the chain rule to test your knowledge about the chain rule, they can design these kind of word questions. Okay? So I need to put a question mark at it. So what is the answer to this? How should we solve the problem? First of all, you need to understand the English sentence. So what is the derivative of this at x equals to 4? What does it mean? It means that first you have to differentiate the function and then replace x with 4. That is exactly what we're supposed to do. But the derivative of f of square root of x, first of all, you need to understand what is the meaning of this. What is the meaning? You have it on the board. The derivative of f of something is which one? Is this one. Okay? Is equal to f of a square root of x totally prime. So what rule I need here? I need the chain rule, because the chain rule is this. If you have totally prime, the chain rule tells you how to do it. Okay, so what you do, you follow the chain rule, but you give the role of g of x to which expression? To a square root of x. So what happens? You can slip the prime in, but there is a price to pay. And the price is to multiply by square root of x. Yes? So then I continue. So this becomes f prime of square root of x. Do I know what to do with this? Very simple. It is in my table. So it is 1 over 2 square root of x. And if you don't mind, let me write it more compactly. So I would say f prime of x goes to the numerator, and then this one, this one. So that is the first part. The derivative of f of the square root of x is what you see on the board. Now, I don't want to do this. I want to know the derivative of this at x equals to 4. So what I do, I will write it again because I want you to understand it good. So the derivative of f of the square root of x at x equals to 4 is equal to... Okay, can you help me to write it down? The derivative of f of the square root of x is calculated. You see it here in front of you. Now the question is not asking you about the derivative of this only. The derivative of this at x equals to 4. This is my question mark. So what should I do? Yes?
Replace x with 4
Where?
on the
Here. So it becomes what? F prime of the square root of 4 divided by what? 2 square root of 4. Agree? But then I have to continue. This is 2 times 2 is 4. And this is 2 again. So it becomes f prime of 2. You see, I get stuck here if I do not have extra information. So that is not wrong. If there is no extra information, you will stop there. But that is given to you. It's minus 7, so you can continue. So the answer is what finally? Minus 7 over 4. So these type of questions are level 3 questions. They are very simple, but conceptually, so if you can solve this problem, it means that you understand what is going on. Yes? So tell me, do you have any problems understanding? So when they say what is the derivative of that, so you know this, they mean this. Okay? And then, whenever you mean this, chain rule comes to your help, and then we use the chain rule and then answer the problem. Make sure that you understand. These are level 3 questions. Any questions? Okay, let me give you another one. This time I want to wait for you, okay? So if you don't mind, let me clean this. I hope that you have it in your memory. Yes. Here, this one you understand?
Yes.
Okay. And now if you read the question again, the derivative of f of x, but at x equals to 4. So it means that after I am done with differentiation, which I am done here, I have to replace x with 4 to find the derivative of at 4. And when I replace x with 4, square root of 4 is 2. It becomes f prime of 2. And then it becomes 2 times 2, 4. Okay, but then I look back to the problem. I see I am lucky because f prime of 2 is given to me. So this I designed this in a way that you can solve it. For example, if I have given you f prime of 3 is minus 7, you reach here and then you get stuck because the information is not relevant. If it is not relevant, you just stop there. There is nothing we can do. But f prime of 2 is given, so I replace them with minus 7. Understandable? Yes? Okay, so now what we are supposed to do, let me give you an example. So let me pause to see if I can. So if h of x is f of g of x, where g of x is x plus the square root of x. No, so, okay. Yes. If f prime of 20 is minus 2, determine h prime of 16. Yes? You see, h of x. These are the questions, level 3 questions, and then you have to use the chain rule. There is no other way. Okay? Because you don't have information about all the functions. You see, I have given you g of x, but I haven't given you f of x. I have given you one piece of information about f. And then I am asking you to calculate h prime of 16. I wait for you, okay? If you can solve this problem, it means that you really understood the chain rule. Let me finalize this problem myself, but I want to ask your opinion, okay? So, you see, the question is determine h prime of 16. What does it mean? To determine h prime of 16, you see, let me tell you, you shouldn't be confused. I don't read the information in the problem. I just immediately skip the information, whatever they are. I go just straight to the point. I want to calculate h prime of 16. What does it mean? If I refer to my previous studies, I know how to calculate the derivative of a function at a point. 2 steps. Differentiate, second step, replace. Okay, so I will do the same thing. So I will come back and differentiate my function. Now I go back to see what I have. I see this relevant information, and hopefully you remember today's lesson, so you realize that it's the chain rule, so you read it from the formula sheet. The differentiation process is finished, and then what I have to do, I have to replace x with 16. G prime of 16, yes? And now I have to answer these questions. So in order to answer my question mark, I need to know this, I need to know this. But this is the same question again, but for g. So it motivates me to differentiate g, which is extremely simple, 1. The derivative of that one is also this. And then I replace x with 16. So it becomes 1 over 2 square root of 16. So it is 1 plus 1 over 8, which is 9 over 8. So that one is done. But what about this one? I have to calculate g of 16 to see what g of 16 is. So it becomes 16 plus the square root of 16, which is 20. So I have fine-tuned these numbers in a way that it works. So then it means that my question mark, h prime of 16, is equal to f prime at which point? At g of 16. But g of 16 is 20 multiplied by g prime of 16, which is 9 over 8. But f prime of 20 is exactly the information provided for me again. So that's minus 2. So it becomes minus 2 multiplied by 9 over 8, which is minus 9 over 4. So that is the derivative of h at 16 by just these piece of information that you see on them. Any questions? So this lesson is not finished. We will complete it later. But this is the conceptual thing. I mainly work with conceptual problems, not very technical problems, but later we'll come back to technical problems as well. Any questions? Thank you.